Welcome back and thank you very much for joining us. If you've just joined, this is Tenfold Live and we are still doing our final touch-ups on 2D and 3D trigonometry. Remember, next week we are moving on to a new concept, so please keep those videos coming on WhatsApp as well as on our Facebook page. We're now going to go to a question that was sent to us by Tebuho. Let's check out the question.
Tenfold, my name is Tebuho, I'm from Restaurant. I just want to say to you guys, thank you once again for the previous feedbacks that you gave me, but there's this last question I want you to help me with. Please, bye.
Right, thank you very much for that question, Tebuho. Well, guys, every time when you get 2D and 3D questions, just like when you get your Euclidean geometry questions, it's important for you to analyze the love letter that you are given by the examiners. That opening statement is very important. Make sure you analyze it fully, and then you take the information from that statement to the diagram. It's going to help you to do a lot of very interesting information. Put on your diagram, and then you can be able to do a lot from that. So we are going to look at the opening statement and try to take that information and transfer it into the diagram and see how much we can do in trying to solve this question. So if you look at this question, it says to us that DC is a diameter of the circle with center O and a radius of R. Immediately after reading that, I'm interested in putting the information on the sketch and see how far I can go in terms of finding enough information for us to be able to do something on this question. So we are told that the radius is R. So every time when I see a radius, I'm going to put the value R on the sketch. So my OE is at the first radius. So I'm going to write R there for this. OD is also the radius. I'm going to write R for this, but there's another one, OB, which is also the radius, so I'm writing R there, and there's also OC, which is the radius, so I'm putting R there. If I continue reading further, we are told that CA is also equal to R. Now, if you look on this diagram, you'll notice that CA is the length outside the circle. It is also equal to R units, so I'm also going to put R there. If I continue further, I am told that AE is 2 times DE. So I don't like working with AEs and DEs. What I would normally do is I will change this DE here and call it in terms of another variable K, because then that is going to make it very easy for you to be able to work with the diagram. When you're working with Ks, instead of working with some side being equal to maybe double the other side or something else. So I'm going to put this one here as K, and then the long side, which is the side AE, I'll put that one as double K. Right, we're also told that angle DOE is equal to theta. There's theta there, we're all looking at it. And we are required to show that the cosine of theta is equal to 1/4. All right, now this is a very good question. Let's go further down so that we can have enough space here. Quite cool. Right, I'm going to start working on this triangle that has got the angle that we are talking about, which is the triangle highlighted in green there. Remember, when you've got 3 sides in a triangle, you can be able to use your cosine rule. So I'm going to use the cosine rule and try to find the side that is opposite to the given angle. So according to our cosine rule, the side opposite to the given angle, which is k squared, is equals to one side there, r squared, plus the other side, r squared minus 2 times r again, cos of theta. If I simplify this further, we end up with r squared plus r squared, which is 2r squared, minus, when you multiply these 2 r's here, you're going to have another 2r squared cos of theta, which is equal to k squared. Please don't make a mistake of subtracting the 2r squared and 2r squared here to get a 0, because these are not like terms. All right, now after this, I'm now going to move on to another triangle. Let me highlight it in yellow here, which is triangle AEO. And if you look closely at that triangle, the angle next to theta here, since this is a straight line, since CD is a diameter, which is a straight line, this angle is in fact 180 degrees minus of theta. So if you allow me, I'm going to isolate that triangle so that it's easier for us to see it. It looks exactly like this. It has A here, it has O here, and we've got E there. The angle that is given there is 180 degrees minus theta. We also know a lot of information. We know that this length is 2K, and we also know that this one is R, and we also know that this side OA here, this side OA is actually 2R. Okay, cool. So if I continue to simplify this, you will notice that we can actually try to find the angle that is, the side that is opposite to the given angle, and this side is the side AF. So 2k squared, applying the cosine rule once more, is 2r squared plus r squared minus 2 times those sides, minus 2r multiplied by r cosine of theta. Okay, cool. If we get ourselves some space here, you will notice that we can simplify this further to 4k squared equals, this one is also going to be 4r squared plus r squared minus, if you multiply 2 and 2r there, you'll get 4r squared cos of theta. If you look at this, well, we've got two equations that both have r and k on them. So what I'm going to do is I'm going to take all these values of k squared and sub them wherever I see k on the new equation which I found now. This is going to leave us with 4 into 2r squared minus 2r squared cosine of theta equals 4r squared plus r squared minus 4r squared cos of theta. So if I simplify further, if you multiply in here, you'll get 8r squared. If you multiply again in here, you'll get another minus 8r squared cos of theta equals to, this is 4r squared plus r squared, which is 5r squared minus 4r squared cos of theta. Okay, cool. So if you simplify this further, you will notice that we can actually group the like terms here. This one is actually friends with that one over there. So I'm going to do witchcraft math and take this one over and bring this one over the side. So this is going to give us 8r squared, right, minus 5r squared equals positive 8r squared cos of theta minus 4r squared cosine of theta. Okay, if you look at this question, there's a little bit of a mistake that we made here, and it's right here. The angle that we're dealing with in this question is 180 minus theta. So if I resubstitute that angle here, it is not cos of theta, but it is the cos of 180 minus theta, which when you reduce, since it's the second quadrant, is going to give us negative cosine of theta, which means the sign that we are dealing with here is not negative but positive cos of theta. So quickly be careful of your reductions there and the correct use of your angles. This is going to be positive here, it is positive here, it is also positive there. Sorry for that. And if you continue, you will basically see that 8 minus 5 is going to give us 3r squared equals to, this one is going to give us 12r squared cosine of theta. And if you're solving for theta, divide both sides by 12r squared. Even this side, we divide by 12r squared. This is going to cancel out, leaving us with the cosine of theta equals to 3 over 12, which gives us the 1 over 4 that we are looking for. So I hope this question was actually very useful for you. You managed to learn a few things from it, and be careful of your reduction formulas. In addition, make sure that you understand how to substitute the correct angles so that you don't make mistakes. We're now going to go to a concept video. After that, Siabonga will be on standby to take the next question.
The Gautrain, an 80-kilometre mass rapid transport railway system linking Johannesburg, Pretoria and OR Tambo International Airport, is Africa's first rapid rail and bus service. On the 8th of June 2010, just 3 days before the 2010 World Cup kickoff, the first Gautrain to transport paying customers pulled out of Sandton Station en route to OR Tambo International Airport. The construction of this world-class system was a true international effort that included engineers, machinery, and technology from around the globe. Most of the rail track tunnels were excavated using drilling and blasting. This means that holes were drilled and filled with dynamite and detonated, causing rocks to collapse, lengthening the distance of the tunnel. Creating a circular-shaped tunnel requires careful calculation of the position and depth of each hole to be drilled and blasted. To calculate this, the Gautrain project relied on data from land surveying. Surveying is the science of determining three-dimensional position of points and the distances and angles between them. These points are usually on the surface of the Earth, and they're often used to establish maps, boundaries, or locations, like building corners. As part of the planning process, the Gautrain project started with geological drilling and logging, conducting of survey work, and the erection of survey beacons. Survey beacons were placed on ground level to act as physical pointers for the final drafting of the train's path. Surveyors work with elements of trigonometry. Triangulation is a surveying method that measures the angles in a triangle formed by 3 survey control points. Using trigonometry and the measured length of just one side, the other distances in the triangle can be calculated. Surface surveying of the Gautrain project required 21 surveyors whose responsibilities covered construction surveying, earthworks and substructure control. Gautrain. Get on track to the future.
Hi guys, it is so exciting to have you guys back. Remember, you can send us more questions if you have any on our Facebook page and on our WhatsApp page. So today we're dealing with a question that was sent to us by Dewey. So Dewey, this is for you and everyone else at home. Let's just have a look at it.
Hi Tenfold, it's Joey here from the West End. I have a question and this is it. Could you please help me out? Thank you. Bye.
So the question reads, a corner of a rectangular block of wood is cut off and shown in the diagram below. The inclined plane that is triangle ACD is an isosceles triangle having angle ADC and ACD being equal to each other and equal to theta. So the important thing there is that it's an isosceles. That makes this to be equal to x plus 3. Now also angle ACB is equal to a half theta. AC is equals to x plus 3 and CD is equals to 2x, which we've already used. Now let's go down to the first question. The first question is asking us, determine an expression for angle CAD in terms of theta. To do that, we'll then look at which triangle is it that we're focusing on. So the triangle here that we're focusing on is triangle A, C, and D. So remember, I have theta there, I have theta here. So now to work this out, you're gonna use the sum of interior angles of a triangle. So angle CAD will then be equal to 180 degrees minus 2 theta. Remember the reason I'm just used to x, so pardon that. Remember that the reason for this will then be sum of interior angles of a triangle. Going to the next question, remember we have this as x plus 3. We have this as 180 degrees minus 2 theta. From there, let's look at what the other question wants us to do. They say, prove that cos of theta is equals to x plus 3. To prove that cos of theta is equals to x plus 3, we're then going to use sine rule. Remember, you can choose between sine rule and cosine rule. What decides which rule to use is whether you have 2 sides and an angle or 3 sides and an angle. So with this one, I have 3 sides and an angle, so I can try and use it, but the shorter route will then be us using sine rule. So let's just have a look at what sine rule has to do. Now, using sine rule, I will then just draw the triangle that we're dealing with as well. Again, remember that. Always take out the triangle that you're focusing on so that you know exactly, you don't get lost. I have that there, x plus 3. This is 2x. This is x plus 3. This is 180 degrees minus 2 theta. Now, in this particular triangle that we have here, remember, I'm going to have to use the 2 theta there because it's then going to change the sine to a cos. So this is going to give me sine of 180 degrees minus 2 theta, all divided by the opposite side. Remember, the opposite side to this will be that one. So this is 2x is equal to a sine of theta divided by, you can choose any because they are equal, then it will be x plus 3. Remember to simplify, this one, if you simplify it, 180 degrees is in the second quadrant, that the sign is positive. So let's have a look at it. Then it will be sine of 2 theta divided by 2x is equals to sine of theta divided by x plus 3. Please remember at home, we are not going to take this as 2 and 2 is going to cancel each other and find the answer from there. That's not what we are doing. This is a double angle. If it's a double angle, then it will be 2 sine of theta cos of theta. All of this will then be multiplied by x plus 3 is equals to 2x multiplied by sine of theta. Sine of theta and sine of theta are common terms, so if you divide by it both sides, it will give me 1. So I will be left with 2 cos of theta multiplied by x plus 3 is equals to 2x. Now, remember the question wanted us to find what cos theta is, so we must make cos theta the subject of the formula. So this will be cos of theta is equals to, I divide by everything that is here, so it becomes 2x over 2 multiplied by x plus 3, which is then equal to the 2, and the 2 will give me a 1, so it is x over x plus 3, and that's the answer that they wanted us to find. Now let's go and have a look at question 3. Question 3, they are saying if it is given that x is equal to 2, calculate AB, the height of the piece of wood. Now, before you can go into this question, there are a few things that you always need to know. We can only use a ratio if the triangle is a right angled triangle. Number 2, we always need to try and know what the angle is that we're dealing with. So that's one of the other ways that you please need to think about when you're doing this particular question. So going back to the question, we're going to draw out the triangle they want us to focus on, which is A, B, and C. I have a half theta here. They want me to find the side, so it's a question mark, I don't know it. Remember, they gave us theta x as equal to 2, so this becomes a 5. And then my theta here, just to calculate what theta is, I will use the question that the answer that we got for the previous question, x over x plus 3, which is equal to 2 over 5. Now to find theta quickly from our calculator, if I pull it up now, so this is what I'm going to have, the second function of cos 2 over 5. This will be equal to 66, this is going to be 66.41. If you just verify quickly from there, so it's actually 421, not 41. So this is 421. Now we need to half it because we're dealing with half theta there. So half of this will be equal to 33.21. I'm sure you can half this just from the top of your head. Now going to the question that they want us to find, they want us to find what AB is. Now to find AB, you know that you're going to use the sine because it is opposite to the theta. So it will be sine of 33.21 is equals to AB, which we do not know, divided by going to the diagram quickly, BC. So BC, we're not going to use BC, it's the adjacent, pardon me there. We're then going to look at AC, which is the hypotenuse side. So AC will be equal to 5. To solve for AB, it will be equal to 5 multiplied by sine of 33.21. To solve for this, we're just going to pull out my calculator down there again. I will then have 5 multiplied by sine of 33.21. This is equals to 2.74. So this is going to be equals to 2.74 units that we're dealing with. Thank you so much, Chewy. That was a very wonderful question that you've sent to us. Remember, please tune in next time and we'll see you guys later.